So let's take another example of integration. Okay, so here again we have to integrate 2x cosine x plus 5 dx. So it is again product of two terms, 2x and cosine x plus 5. So as it's a product of two terms, we cannot integrate it directly. Now how do we know that this specific question is integration by parts? Because if for 2x, if we look for the rule of integration, we can use this rule, x power n dx. Okay, and if we look for the rule of integration for cos x plus 5, we have this rule, cosine ax plus b, which is equal to sine ax plus b over a. So for both the terms which are under multiplication under integration sign, we have the direct rule. But as we cannot apply the rules directly to the individual term, we have to go through the method of integration by parts. Now what the method says, this is the rule for integration by parts. It is integration of v du, which is equal to u times v minus integral of v du. So it means we have to compare the given integral with u and dv, and we need to find the value of u and dv. Now how do we select that which term is u? Either 2x is u, or we will take cos of x plus 5 as u. So for that again we have a rule. It's I-late rule, but since in this part we are not considering inverse trigonometric function, let's consider for the late rule, and it's easy to remember, late. The word late is very easy to remember. Okay, now L stands for logarithmic function, function of the type ln of 2x plus 3 or ln of x. Okay, A stands for a polynomial or algebraic function. It can be a function of 2x plus 3 or simple x or x square, like that. T stands for trigonometric function, sin x, cosine x, tan x. E stands for exponential function. So now we number them from 1 to 4, and then we have to select u as the term which is coming first. So if we see our function 2x, it belongs to which category? It belongs to algebraic function, which is at position 2, whereas cosine belongs to t, which is at position 3. So 2 comes before 3. So algebraic function comes before trigonometric function. So we will select u is equal to 2x, and whatever left we consider it as dv. So once 2x is gone, we left with cosine x plus 5 dx. So this total will become cosine x plus 5 dx. This will become dv. Now what the rule says? In the rule, we need the value of u, we need the value of v, and we need the value of du. U we already have from the question. This is the value of u available to us, but we don't have v. Now we have dv. From dv, how do we get u? Yes, we have to integrate. If we integrate dv, we will get the value of v. Similarly, to get du, what we should do? We should differentiate. So this is the step. So once we have u, we differentiate u with respect to x. How do we know that with x? Because of dx. So it is 2. So this gives you the value of du as 2 dx. And here when we do the integration of cosine x plus 5 dx, by using this rule, this gives us the value of v as sine of x plus 5 divided by 1, because the coefficient of x is 1. So no need to write. Here we will not add the constant of integration at this stage, because these values we are going to substitute in this rule, which need further integration. So let us substitute the value of u, v and du in this formula. So what we will get? We will get it is equal to u, which is 2x, times v, which is sine x plus 5, minus integral of v sine x plus 5 times du is 2 dx. 2 dx. So we use the value of u times v minus v times du. So this is equal to, now the first term is already integrated, so no need to change, keep it same, sine x plus 5 minus, now 2 is the constant of integration, we take it outside, integration of sine will become minus cosine x plus 5. Now since all the integration finished, we'll write the constant of integration c. Now let's simplify it further, gives you 2x sine x plus 5, this minus minus become plus 2 cosine of x plus 5 plus c. So this completes our solution.